Good evening everyone and welcome to my YouTube channel. So here today we are going to be drawing the 20 amino acids. So we are going to group them into the non-polar, those that do not dissolve in water. We have the polar, those that dissolve in water. We have the electrically charged, which can be negative or positive. So we can have the negative or positive. So those are the electrically charged. So let's begin. So let's start with our non-polar. So the non-polar that we are going to have are, so you can just remember this mnemonic, gap-vium. So the gap-vium, we are going to have the glycine. We are also going to have A is for alanine, then P is for proline, then for V is for we are going to call this one valine like that. Then we have I is for isoleucine, L is for just leucine, then we have M is for methionine. Now we are going to follow this order. It is very good in the sense that, so here what we are going to have is that an amino acid will look like this. So we have the C, another C, we have bonded to an alcohol, bonded to an amine like that. Then we have an hydrogen there. Then down here we are going to have what we are going to call the ARA group. So this is the thing that will be changing. So the ARA group is what will be changing, but these will just remain intact. H3 positive charge like that. So these will remain intact like that. So you will find that on its own an amino acid is not charged, in the sense that the negative and the positive tends to cancel each other like that. For other books, they might give you C double bond O, then it is bonded to OH. Then on this other one, it is just like that. So this is what we refer to as an amino acid. So now, to connect it with this is very easy. Glycine or glycine, we can have the R is just equal to H. So as you can see, R is equal to H. Now for this video, when I say CH3, I'm going to be using the word methyl. So when you see CH3, that is just methyl. So already when we are looking at glycine, we are going to, where there is the R group, we are just going to have H like that. So now we are going to have, let's move on to our next one. So glycine is done. Let's look at our alanine. So changing the R, so this is glycine. So alanine will just take what we are going to call methyl. So the methyl is CH3 like that. So that means to say the alanine is done like that. Let's move on to our next one. So before we go to proline, because it's a different type of the structure, we are not going to go to that one. First, let's move on to, so the P, let's keep it for now. Let's go to valine. So valine, we have something like this. So for this one, you're just going to have your R should be equal to, you're just going to have your CH. Then you are going to say 2-methyl. So this is how you can remember it. Already the mnemonic is made in such a way that it is getting more and more complex. Valine, it is now CH. Now this one just had 1-methyl. So you are just going to say CH2-methyl. So that means to say if you have this structure, you are going to have something like this. So for our valine, we are going to have, where CH3 is, we have said it is CH. Then we are going to have our C 2-methyl. So we have said 2-methyl. So we are going to have CH3, another CH3, like that. So that means to say you have drawn the structure of Volene like that. So when we look at our leucine, it is the next one. Now remember, our Volene looks like this. So this same structure is the same as well, but the only difference is that before this you are going to add your CH2. So this one has got an arrow which is equal to CH2, then you have your CH, then you are going to say 2-methyl. So what you are going to have is this structure. So remember, it is equal to CH, so CH, then we are going to have our CH2 like that. As we have said, CH2, then we are going to have C, then we are going to have our 2-methyl like that. So we have H like that, so we can just write it like this. So this is what we have. So this is what we are going to call our leucine. Now it is very, very important for you to just know leucine. Then for isoleucine, you're just going to change the position. So just change position. So yeah, we said 2-methyl, so here that's the 3. When we look at isoleucine, so isoleucine, this one is exactly the same, but the only difference, so we are just going to use this same diagram, but what we are just going to do is that we are just going to move this so that it just becomes our CH there. Then we are going to move our CH3. Everything is the same. Remember, we had our CH2 there. So let me just write it properly. So we have our CH2 like that, then we have our CH3. So it's just the same, but the isoleucine, meaning to say it is just the change in how the atoms have been arranged like that. So just know one. When you know one, which is the first one, then just interchange by getting the CH3 on top there. Just not to say hydrogen can accommodate 4 bonds, so that's how come if you have H2, you have 1 bond, that's 4. So 2 plus 2 is 4. So each carbon must have 4 bonds like that. So this is what we are going to call our isoleucine. Methionine, on the other hand, this word theo, though an L is missing, means to say the sulfur is present. So the structure of methionine is such that it has got 2 of the CH2, and it has also now what we are going to call the, so what you can just do is that to remember this, you can just say 2CH2, then you are going to say methyls to show this small s, means to say you are not saying that there are many methyls, but this s means the sulfur. So to draw this structure, you are going to say something like this. So what we are going to have is we have said 2CH2, then we are going to write CH2, another CH2 like that. Then the methyls, this S is for sulfur, so it is a theo, means there is a sulfur, so we can say sulfur like that. Then the methyl part is now what we are going to call the CH3 like that. So the other thing is we are going to have what we are going to call now. Let's go back to our proline. This one is a bit unique, but what I love to think about is what we call pro. You cannot go pro if there are only 2 people involved, so pro has to begin at 3. So this one forms more like a triangle in such a way that we are going to have our 3CH2 throughout. Now what happens is this. What we are going to have is something like this. So in this case, nitrogen can accommodate 3 bonds. Now the pressure is that we are now going to have we have said that we need our 3. So know this structure. Then we are going to take another one, CH2, like that. Then it will bond to nitrogen, but nitrogen can only accommodate 3 bonds, so this one will be reduced to 2, like that. So this is the structure of what we are going to call proline, like that. Other structures that we have the phenylalanine. So remember, alanine is the one that has got the methyl, just the CH3 there. Now for phenylalanine, this is an aromatic amino acid, meaning to say it has got a benzene ring. So now we know that carbon, it is already bonded to one of the carbons there. Carbon can only accommodate 3 bonds, so that means to say for you to add another thing, you have to remove 1 hydrogen, so that 2 plus 1, it will be 3. Then you shall connect to it what we are going to call the benzene ring, like that. So this is the benzene ring. So that is the phenylalanine. Let's draw the structure. So we have said CH2, then we are going to have an aromatic ring, which is a ring that looks like this, like that. So this is our aromatic ring, like that. So this is our phenylalanine. Now things are getting more and more interesting. The other aromatic ring that is non-polar that we are going to have is a tryptophan. So we have the tryptophan. So by spelling the word part-time, this can help you. Just spell the word time with 2 letters. This can help you to remember. We have the phenylalanine, we have tryptophan, and we also have tyrosine. So these have got the aromatic ring. We also have what we are going to call histidine. So now let's draw the structure for tryptophan. So the good part about these with aromatic rings, they all have got the common structure, which is the CH2, which will help you like that. Now for this one, it has got a pentose ring, like that. We have it's something like this. So we have something like this. So we have, then just think of the last 2 words on tryptophan. We have N, like that. So you can add a nitrogen like that. So nitrogen N, like that. So this is the structure of tryptophan. Then since tryptophan, as you can see, part-time, meaning to say it's coming after the word part, so you are going to add an aromatic, the benzene ring, sorry, like that. So this is the structure of what we are going to call tryptophan. So just know to say at least the CH2 is common throughout, like that. So we have exhausted the non-polar, though the tyrosine is not non-polar, but it is not non-polar, but it is an example of a structure having an aromatic ring, like that. However, when we are looking at the polar has got so the mnemonic for this one that I have made is stuck glue, like that. So this will help you. So already it dissolves in water, meaning to say it is stuck in water, and what makes things stuck is glue. So to look at this mnemonic, we have S is for serine, then we have so we have our serine, like that. We also have our threonine, then we have our T, which is our tyrosine. As I said, this is an example of an aromatic amino acid. Then we also have our A is asparagine. Then when we have our C is what we call cysteine. cysteine or cysteine, like that. Then we have our G finally, which is just glutamine. So to remember these, let's group them in 2, 3. We have serine, we have 309, and also what we are going to call tyrosine. So all these have got one thing in common. They all have what we are going to call the OH, the hydroxide. So let's be able to draw those. So the common thing about serine is that it has got CH2. This one has got CH2. So let's begin with these two. The simplest one is serine. We are going to have our CH2 like that. Then we are going to have our OH. Very simple. Then when we look at our tyrosine, just as I said, tyrosine is an aromatic amino acid. So it is also going to have the CH2. Then you are going to attach the benzene ring, then OH. So we have our CH2 like that. Then we are going to attach a benzene ring like that, which will look like something like this. So this is what we simply refer to as then attach an OH like that. So this is basically what we refer to as tyrosine. Then the next one is what we are going to call the 309. So one peculiar thing that you have noticed is that for every word that is beginning with T, anything, it has got 3 items. So beginning we have the tyrosine. When we look at tryptophan, so this was tryptophan, it has got the CH2, it has got the CH2, it has got this ring, it has got another ring to add up to 3. Then when we look at our tyrosine also has got 3 items. We have this one, we have the benzene ring, and we also have this one. So anything that has to do with T, just think of at least 3 items. So how do you achieve 3 items? Let's draw the structure. So already we have established one thing, and that thing is that it should have an OH. Now what we are going to do is that we are going to have our CH like that. Then CH is, if you remember other structures, it is accompanied by a methyl. So you can say CH, just remember CH methyl like that. So if you remember CH methyl for this structure, then just know to say for this one, you are just going to add an hydroxide. So 3 things. So we have the CH, CH3, and our OH like that. So now, if you forget, you can just first write stack glue, write all the names, then identify these 3 which have got an hydroxide like that. So cysteine also has got what we are going to call our thio. So our thio meaning to say, thio simply means to say, thio simply means to say there is a sulfur. So for this one, so we have the CH2, then we are going to draw the thio, which is just C, then it is bonded to H like that. So now you should be comparing the structures so that you can remember. Find a way of memorizing. The CH2 is the common thing. CH2, we have the SH like that. So as long as we have 2 things, expect a structure to look like that, where we have the CH2 like that. So we also have our glutamine and our arginine. So the word amine means to say we are going to have our NH2, then also we are going to have a double bond to oxygen like that. So that's the implication. So now both of these, arginine or asparagine, also has got this structure NH2, then we also have an O bonded like that. So now what you can just do is that both of these structures have got the CH2. So what you can just do is that since A comes first in the alphabet, meaning to say it will just have one CH2, then this one shall have, since G comes later, it shall have two CH2 like that. So in such a way, that's the only difference that's there. Let's draw the structure. So we have said we have asparagine. So the structure is we are going to have our CH2, then this CH2 shall be bonded to, we are going to have a structure of 2 oxygen double bond, then we are going to have our NH2. So at least if you know, you can think in those lines. Then we are going to have our glutamine like that. So this glutamine shall look like something like this. So the structure is the same, but for this one you just have to double, just as I said. Then you are going to now draw the exact structure. We have the NH2, then we have the double bond with oxygen like that. So we are just remaining with 5 of them. So we have on the electrically charged. For this one you can just use the mnemonic lager. So now for this one, L means we are going to have our lysine, then we are going to have our A, we are going to call this one as our aspartate, then our G, we are going to call this one as our glutamate, then we have our A, we are going to call this one as our arginine, then we have our H, we are going to call it our histidine, like that. So now let's begin with our first ones. We have aspartate, then we also have our aspartate. Let's begin with our aspartate and our glutamate. So these two, as you can see, we had also glutamine and our asparagine. So the opposite of these will be the charged. So now instead of adding the NH2, aspartate is acidic, so you are just going to add an acidic, which is our C double bond like that. So this is what we refer to as an acid. Then for this one you are going to do the same. The CH2, there will be 2 of them, just as we did for the last time, then attach an acid like that. So this is going to look like something like this. So we have, so remember A comes first in the alphabet, so we said it's CH2, then just attach the substance like that. Then we have this one, same approach. We are going to have our CH2 like that. Again we have our CH2 like that. Then we are going to have the C bonded to O, then 1 bond negative like that. So that's the charged part like that. Then let's move on to our lysine. So our lysine will look like something like this. So for lysine we are going to have something like this. So R group will be equal to 4CH2. So there will be 4 of these plus the NH3 like that. So that is basically what the lysine is. So it is charged. So this is what is making it to be charged like that. Let us draw the structure. So we have 4CH2 plus our NH3 like that. So it is just about the side chain. So we have said CH2 4 times, CH2, CH2, CH2 like that. Then we are going to attach now what we are going to call our NH3 with a positive charge like that. Then the good part is that the only charged in terms of the negative is this one, these two. Then the rest we are just going to be dealing with the nitrogen. Now the only difference is that we are going to have histidine is an aromatic. Then this other one, we are going to go to our arginine. So our arginine will look like our 3. Instead of having 4, we are going to have 3. So remember, we have, for this one we have 1 NH3. For this one we are going to have our 2. So you can name them in that order, lysine then arginine. So we are going to have 2. That means to say, if here we had 4 CH2s, here we should have 2. So 1 2. So that means to say the CH2s should be 3. It should reduce since we have increased the number of NH, like that. So this is going to help you to remember. So your R group will be equal to 3 of the CH2s. Then you are going to have also 3 your NH, sorry, not 3 NH, but just 2 NH2. But you are also going to have, this one is a bit complex like that, then there will be an addition of a carbon bondage there. So let us draw the structure. So we are going to have our 3 of them, CH2, CH2, like that. Then what we are going to have is that this one, it has got 3 carbons, 3 nitrogens. So now nitrogen can accommodate 3 bonds. So meaning to say, if we have here, now we are going to have carbon like that. Then carbon on one side, it shall have a double bond. On the other, it shall just have NH2. So remember, I said 2 NH2, like that. Now if carbon, if nitrogen has got needs 3 bonds, it means to say it needs to be bonded with another. So here you add a nitrogen there. So here it will be a positive charge, like that. So this is the structure of arginine, like that. So last but not the least, we have our histidine, which is an aromatic, meaning to say it has got a ring structure. So for this one, it's a simple structure. So remember, all of them have got the CH2, then the ring. From here we are just going to draw the ring structure, like that. So the ring structure, then our NH will be able to show like that. So we have NH, 2 of them, like that. So this is what we have, like that. So that is how you draw the 20 amino acids. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.